What up, calculus students? We are getting into the understanding of second derivatives. And the key is that a second derivative sign tells you if the first derivative is increasing or decreasing. We're deeper into the dream state. We're at a next level. But it turns out that it tells us how our original function is curving. So we've already understood that a slope tells us if something is increasing or decreasing. F prime is the slope of f at 1. It's telling us, oh, what's -1? Yeah, fine. So 3 plus 4, which is 7. It's telling us f's slope is +7. It's telling us that f is increasing 7 y's per x at x equals 1. Cool. Well, f double prime would be the slope of f prime. F double prime is the slopes of the slopes. This is -12 at -1. F double prime of -1 would be -10. It's late in the day on Friday, and I'm making this video. Helped a lot of students today, though. That was fun. And this would be the slopes of f prime, the slopes of the slopes. So the slopes of the slopes are decreasing by 10 y's per x because it's like how the slopes are changing. We'll like to say just like f prime is decreasing 10 y's per x at x equals -1. But it also tells me that f is concave down at x equals -1, because if our second derivative is negative, yes, our first derivative is decreasing, but our original function is curving downward. Okay? All right, what intervals is f prime increasing? F prime is increasing when f double prime is positive. How do we figure that out? We do a sign analysis of our second derivative. How do we do a sign analysis? We look at the zeros. Those are the interesting points. And we'll have negatives to the right, positives there, which means f prime is increasing and decreasing, which means f is curving upward, curving downward. So I would say x is less than 0 or -infinity to 0, and I say f is concave up on that interval because f prime is increasing. Cool, same thing here. F prime, we're going to blow past because we're going to do a, oh, jeez, I screwed up. This should have been like a squared. But whatever. F double prime is just 12x squared. Oh, okay, cool. That's fine. If I plug in 0 or set this equal to 0, I get 0. But I'll have positives on both sides, which means f double prime is increasing and then increasing, which means f will be concave up. There will be one point where there's no concavity, and then we'll be back to being concave up. It's not going to be a point of inflection. I would say -infinity to 0 and 0 to infinity. I would not include 0, as that's a point where we have no concavity. All right, I kind of threw this into the homework, but this is more of something that's going to show up next class where we talk about the rate of change of f. Well, the rate of change of f, I hope you understand, is just how f slopes are changing, or like the rate of change of f are f slopes. That's the rate of change of f. And we're trying to figure out what f's rates of change, the rate of change of f, the slopes of f are decreasing. This question is really asking you to figure out when f double prime is negative, because then the rate of change of f is decreasing. That means f is concave down. I'm going to break out this more rate of changey questions next class. Rate of change increasing, rate of change positive, rate of change negative. But it's just a slope. Cool. What does that tell you about f? F is concave down. So we go to our second derivative. We have a interesting point at 3. We'll have positives, we'll have negatives, which means f prime will be decreasing then increasing. The rate of change of f is f slopes. F slopes are decreasing from negative infinity to 3. And that tells me that f is concave down. Negative 4 6 x cubed. I'm just going to leave it like that. I don't know why I gave you negative 1/6. Negative 12 6 x squared. So that's negative 2x squared. Cool. When is the rate of change decreasing? The rate of change is the slope of f. How is f changing? How is f changing? Look at the slopes. I feel like I should have talked more about what is a rate of change. It's the instantaneous rate of change. Yeah. It's like we have talked about rates of change. Rates of change are just slopes. All right, cool. So f double prime, again, I'm like tired. It's late on for 3:30 on a Friday. Crazy. I've been sick all week. I have a wedding this weekend. Test points, plug in 5, negatives, positives. The factor will change signs at 3, so that would be a negative, negative. The factor will change signs at 0, positive. Use test points. Evie, little video bomb. Guys, that was Evie Flynn, okay? Forever, she will be on this calculus video. It's your homework. I'm a little tired, though, so I'm a little loopy. It could be a fun one. All right. All right, cool. Now we're just going to go and do points of inflection. Points of inflection are when f double prime changes sign. And I hope this works out. It should. Nope. Yeah, I don't want to do that. I had a feeling this wasn't going to work out. Changed my mind. Sorry. Yes, you could use the quadratic formula. Ugh. But I've never seen a quadratic formula show up on the AP Calculus exam. It'd be funny if this would be the year that it did. So I'd want to divide this by 2 to make it 18. No. I want 24. 24. 24. 24, guys. 24. Put your phone away! Freshman. Alright, this is a 24. And this is 24. How can that be 24x? 12. Yeah, 12. Cool. Mobby. There's my second derivative. I got negative 1 and 2. Positives, negatives, positives. We will change signs. Which means my first derivative is increasing, decreasing. We're concave up, concave down, concave up. Which means x equals negative 1 and 2 are points of inflection. Great. Since we're going straight to the second derivative, minus, might as well just keep it simple. And I get negative x cubed minus x. Ugh. Going to factor out and negative x. Oh my gosh. I screwed up on this one too. Sign should have been different. Who made this homework? This guy. There are no solutions from here. X squared plus 1 is never 0. It's only positive. The only solutions at 0 will be negatives and positives, which means we only have 1 point of inflection at 0. There are no solutions to x squared plus 1 equals 0. So we're looking at concave up, then concave down. Hey, Sia. How's it going? So, let's see if that's right. Yeah, concave up to concave down. Lame function, Mr. Master. Yeah, I screwed up. I think if it was a plus, it would have been better. Look at that. Just one simple. We'd have lots of concavity changes. Look at that. Concave up to concave down to concave up to concave down. It would have been a lot nicer. All right. Good. Get there. This one will be fun. Sign analysis of our second derivative to tell us about our first derivative, to tell us about the curvature of the original function. We got 0, we got 3. If I plug in 4, negative, positive, negative, so that's going to be a negative. I know I'm going to keep the first factor to be positive because it's got a square in it. I know that the other factor will change, so that's why I got negatives. That's a positive. Positives. Plug in 1, positive. Plug in -1, positive. So f prime is increasing, flattening out, increasing, then decreasing, which means f is curving up, flattening out, curving up, curving down. What's really important is that x equals 3 is our only point of inflection. X equals 0 is a point of no concavity, but it is not a point of inflection where our concavity changes. Cool, this one shows up a lot. We've seen it on our homework a couple times because it will be on our test. And we take our second derivative, we set it equal to 0. I'm going to subtract a cosine x and to divide by a negative cosine x. So, or just divide by -1, then divide by cosine to get tangent x equals 1. All right, so I have the pi over 4s in the first and the third quadrants when tangent equals 1. If you need to remember how to do this, please come in and I will remind you. Now, we got to go back to our second derivative, not its simplified version or what we did to solve. And we need to plug in values like 0, like pi. We could assume that signs are going to change, but not safe to assume. 3 pi over 2 is a good one. If I plug in 0, I get the sine of 0 plus the cosine of 0. The sine of 0 is 0. The cosine of 0 is 1, so we got a positive. If I plug in pi, I got the sine of pi, which is 0. Cosine of pi is -1, so that's negative. 3 pi over 2, the sine of 3 pi over 2 is 1. Take a negative, it's -1. The cosine of 3 pi over 2 is 0. So, ooh, wait, what? Oh, I'm taking the opposite of -1, which is why it's a positive one. So, f prime is increasing, decreasing, increasing. F is concave up, concave down, concave up. I would consider pi over 4 and 5 pi over 4 as points of inflection. Great. Ooh, tricky. I'm already given f prime. When does f have a point of inflection? Look at f double prime. You're already given f prime, so don't go much further. Set this equal to 0. I get plus or minus root 3. Negative root 3, positive root 3. F double prime. F double prime. Plug in 0, negative, plug in 12, positive, plug in negative 12. It'll be a positive. Okay? That's when f prime is increasing and decreasing. That's when f is concave up, concave down. When is f concave up? From negative infinity to negative root 3, and from root 3 to infinity. When does f have a point of inflection? Points of inflection are going to be at x equals negative root 3 and x equals positive root 3. Oh, I'm already giving you the second derivative. It's already factored, so we just need zeros. You already have everything you need. You just have to do the sign analysis. Positives, not going to change signs. Going to change signs, not going to change signs. That's fun. We only have one point of inflection. The only point of inflection is at x equals 3. When are we concave down? I'd say negative infinity to 0 and 0 to 3. That's when f is concave down. All right, to my favorite questions. Can't just memorize what to do. You got to be ready to adjust and adapt. You got to look at the correct characteristic of the graph that's given to you to be able to answer the question. What will help you is your friend. You're good. Mr. Second Derivative, which tells you about the first derivative, which tells you about curvature. Cool? Now, your second derivative signs will tell you about your first derivative's direction, which will tell you about your function's curvature. You need to pick the correct layer of things based on what graph's given to you. So when does f have a point of inflection? That's when f prime will change from increasing to decreasing, or vice versa. It'll change directions. Or you know that f prime is also, or f double prime is also the slopes of f prime. You remember the questions from day 1 where I asked you, when are the slopes of this graph positive? And then I asked you, when is this graph increasing? And you'd be like, oh, the slopes of the graph are positive from 0 to 2. And then you're like, oh, the graph is increasing from 0 to 2. These are the same answers. Yes. Slopes being positive is the same location as when something is increasing. So it means you have two options. You can either say f has points of inflection when the slopes change sign. Okay, we'll have positive slopes and negative slopes. These are slopes. Or when f prime changes from increasing to decreasing, or vice versa. That's at x equals 0. When is f concave up? F is concave up when f double prime is positive, which are the slopes of f prime being positive, or when just f prime is increasing. F prime is increasing. F prime is going up from negative infinity to 0. We practice giving the correct intervals from lesson 0. Now we just have to make sure we're looking at the correct characteristic to answer the question. Okay, so this is f prime again. This is f prime again. F prime. Going up, going down, going up. F prime's slopes. Positive, negative, positive. F's curvature. Up, down, up. Points of inflection. Where we change from going up to going down. Boom. When we change from going down to going up. Boom. X equals negative 1, x equals 1. That ends up being the max and mins of f prime. When is f concave down? F is concave down when f's slopes are negative, or when the slopes, when f slopes are decreasing, or when the slopes of the slopes are negative, or the slopes of f prime are negative. So when is f prime decreasing from -1 to 1? Cool. So the rest of the ones are the same. I want to get to the next question. Points of inflection, -2, 0, and 2. Don't memorize this, though, guys. Don't memorize this. Instead, keep to the chart. The chart is the key. The chart is memorized, and then the characteristics are found. F is concave up. F is concave up when F prime is going up. Here I'm going up. Here I'm going up. -2 to 0, and from 2 to infinity. Okay. F prime is going down, then going down, then going up. So I would say my only point of inflection is at 2. I would say I'm concave up from 2 to infinity because F prime's slopes are positive when F prime is going up, or when F is concave up. You can even look at this. You can look at the slopes of F prime. These slopes are positive. Yes, the function is going up. Changing it up. What if I give you the graph of F double prime? This is a big star. Star, 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 star. Star, star, star. Change it up. Like, look at this question. When is F concave up? When F double prime is positive, F prime is increasing, F is concave up. Well, since I have the graph of F double prime, I should be looking at this characteristic. I should be looking at when F double prime is positive. We are looking at when this graph is positive. This graph is positive from -3 to 2. That's the answer to the question. It's a different characteristic than if I look at F prime. We have to look at the correct characteristic of the graph to answer the question based on this analysis. Where do we have points of inflection? Well, points of inflection are when F double prime changes sign, when F prime changes direction, or when F changes concavity. Well, F double prime changes from positives to negatives or vice versa through a 0. We realize it's kind of like day 2. We're looking at positive and negative things. Cool? F double prime negative, F prime going down, F concave down. But this is F double prime, so I'm looking at when F double prime is negative. Here is when F double prime is negative, from -infinity to -2, and from 0 to 2. When does F have points of inflection? That's when F double prime is going to change sign. Since this is the graph of F double prime, we're good. X equals -2, X equals 0, X equals 2. Okay, but what if I give you F? Well, guess what? You got to look at the curvature, maybe, of F. Looks like we have a point of inflection right here at X equals 1. That's where the curvature is going to change. We're actually looking at the graph now. But then we break out this guy. What is F double prime positive? That's F double prime positive. Oh, that's when F prime is increasing. That's when F is concave up. I'm looking at when F, this graph, to answer this question, F double prime positive, I should be looking at when F is concave up. This entire region is when F is concave up. So all x's less than 1 or -infinity to 1. Cool. Where are the points of inflection? -2, 0? Sure. How do you know that? I don't know. Like, you'll usually be told where the points of inflection are. When is F double prime less than 0? That's F double prime negative. That's F prime going down. That's F is concave down. Since this is the graph of F, I should be looking at when F is concave down. Did I not give you one of those positive, -0 questions? Where did that go? Oof. This is not my best homework. Gotta freshen this up. All right, so it looks like we're concave down from -2 to 0. All right, that works. I think I give you the order things on the next homework. What's great is like we're pretty much done. We know all the material that we need to know. The only thing that we're doing lesson 4 is smushing lesson 2 and 3 together so we can have a full sign analysis, a full graphical analysis of a function. And boom, we'll be good to go. We'll be human graphing calculators after next class. Then we got a review day, then a test day. So that's fun. All right. Have a great weekend. You're not going to watch this till Monday, though, or Tuesday. But that's so cool. It's fine. Still hope you had a great weekend. Peace.